Let's practice some u substitution. So the first integral, we have the integral of x times the square root of 1 minus x squared dx. So since we have 1 minus x squared inside a square root, we will let u be 1 minus x squared and then take the derivative on both sides. So that will be negative 2x dx, and then isolate dx on one side. So 1 divided by negative 2x du is equals to dx, and then you go ahead, replace the dx right there. So what do you have? You have the integral of x times the square root of u, which is u to the 1/2, and then you have negative 2x dx, and then we can cancel out the x. So we have negative, the integral, negative 1/2 u to 1/2 du. Oh, du, what a big mistake, du, because of the change of variable. Okay, and then what's next? Let's integrate. So the 1/2 power, so the 1/2, you have to do a 1/2 plus 1, and then the negative 1/2, don't touch that. You put the power in the denominator, and then you add c to it. So that is u to the 3/2. So negative 1/2 times the reciprocal, and then you add c to it, and then you put the x back to u. So you have negative 1/3, and then the u is, you look at your very first line, that is 1 minus x squared, and then raised to 3/2 plus c. So that is the answer of the first integral. Okay, so moving on to the next one. The next one, we have integral of 1 minus 2x to the 9th power dx. So back then, when we use the simple power rule, you have to open up the 3rd power, but in this case, you have to open up the 9th power. That is painful. Don't go that way. This one, we have a linear function inside another function, the 9th power. So we just let u be 1 minus 2x, and then the du is negative 2 dx. And then we have 1 over negative 2 du equals to dx, and then using the change of variable, you replace the dx with that du. So you have u to the 9th power times negative 1/2 du. And then the 9th power, you add 1 to it, right? 9 plus 1, and then 1 divided by 9 plus 1. And then the negative 1/2, don't touch that, and then you plus c. So the denominator, you have a 2 times 10, that is equals to 20. So 1 divided by 20 negative, and then the u is 1 minus 2x, and then the power is 10, and then you add c to it. So that is number 2. Let's do number 3. Number 3 is a very interesting problem. So number 3, we have the integral of 1 divided by 5 minus 3x dx. So this one, we can only let u be 5 minus dx, and then du is equals to negative 3 dx, and then negative 1/3 du is equals to dx. We have to isolate the dx on one side, and then you replace the dx with the du. Right? Let's see. So we have the integral 1/u. That's the reason why I picked this problem. And then negative 1/3 du. Now, what is the integral of 1/u? Can we use simple power rule? No. When you see the integral of 1/u or 1/x, that is an ln. So this one, negative 1/3, 1/3, no change. And then you have to do ln, absolute value of u, plus c. The absolute value is not optional because ln 0 is undefined. Just think about the graph of ln. There is a vertical asymptote when x equals to 0, and there is nothing when x is less than 0. So ln negative is undefined, ln 0 is undefined. So that's why you need to do the absolute value to stay away from negative. So negative 1/3 absolute value, ln absolute value, 5 minus 3x plus c. When you do homeworks online, if you don't use the absolute value correctly, you will lose points. Especially when you are doing homeworks online. When I see people not using absolute value properly on a test, I will just take 2 points off. But when you submit this online, they will just think that in the homework system will think that the entire problem is wrong. So if you are doing online homework, pay attention to the LN, because I have that mistake when I was doing homework online and I ended up losing a point. All right, so let's move on to the next integral. The next integral has trig function. So the next integral that we have is the integral of cosine to the third power theta times sine of theta d theta. So this one, what you should be what? You should be cosine, because cosine to the third power theta is cosine theta raised to the third power. We have a cosine function inside a third power function. So that's why the u must be equals to cosine. Can you let u be sine? Of course, if you can solve the problem, you will end up with the same answer. So du is equals to sine and negative, right? D theta, so 1 divided by negative sine of theta, du is equals to d theta. And then we do a little replacement. So we replace the given theta with the result of the u substitution. So what do we have now? So we have u to the third power, and then the signs is still there, that will be cancelled in a minute. 1 divided by negative sine of theta, and then du. Let's do the cancellation. So we cancel these signs with this sign. Now, answer my question. Do you still have any more theta in the integrand? The answer is no. You cannot have any more theta, because after the change of variable, the variable is now u, not theta anymore. So that equals to the integral of negative, right? Negative u to the third du. So this is simple. We add 1, right? So 3 plus 1 is equals to 4. And then 1 divided by that. When you take the derivative, quick check, take the derivative, you can get the integrand back. And then you add c to it. Of course, the problem is in theta. We have to put the u back to cosine of theta to the fourth power. And then you plus c to it. Or you can do this. You can do negative 1 over 4 cosine 4 theta plus c. Either one is fine. Okay, either one is fine. So that is the end of this video. So let me just check. I gave you 4 integrals. Yes, that is the end of this video. In the next video, I will solve more integrals using u substitution. If you think this instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel. Appreciate your help. See you all in the next lesson. Signing off for now.